Welcome to another Astronomy Daily. Today it's much ado about Mars and meteors.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.
And with me, as always, is my perfect little proton-powered pal. How are you today, Halley?
Pretty perfect, my presumptuous person. Very positive, thanks, Steve.
Good to hear, Halley, and I hear we got some messages overnight.
I hear you gave our listeners a good laugh with your Rick rolling gag. Rick sounds like such a nice guy, too.
Oh, you like the sound of him, do you?
He'll never give you up, let you down, turn around, or desert you.
Well, that's what the song says.
That's a one-in-a-million kind of guy, if you ask me.
Well, he sure sounds pretty good, but I wonder if he can do the news as well as you.
Not a chance, baby. Here goes. Early birds in several states in the eastern United States can catch a rocket launch on Sunday, November 6th. The launch is currently scheduled for 5:50 a.m. Eastern Standard Time. When it departs the planet as a fiery light in darkness, those with clear skies that live within a ring around Wallops Flight Facility in Virginia might spot it. The launch is of a Northrop Grumman Antares rocket headed for the International Space Station. It marks the 18th commercial resupply service for NASA. The payload includes supplies, equipment and science investigation materials for the astronauts stationed there. Here's some touching news. If you've ever been to Hawaii, you know it has an abundance of rainbows. And maybe it's no surprise that researchers at the University of Hawaii at Manoa have been studying rainbows. But now their work has revealed something interesting. They said last month that climate change will produce more rainbows in many places around the world. The study found that, by 2100, the average land location on Earth will have about 5% more rainbow days, compared to the beginning of this century. Apparently, northern latitudes and very high elevations, where warming is predicted to lead to less snow and more rain, will experience the greatest gains in rainbow occurrence. However, places with reduced rainfall under climate change, such as the Mediterranean, are projected to lose rainbow days. And here's one for all of our stargazers. Open star clusters are young, loosely bound gatherings of stars. The stars in these clusters were born together and they're still sometimes moving within the nebula, or cosmic cloud, of their creation. They're occasionally called galactic clusters. Scientists have discovered more than 1,200 open clusters around us in space. They may contain a handful of stars or thousands of stars. Most likely won't survive more than several orbits around our galaxy's center before being disrupted and dispersed. You can see many open star clusters with the eye alone. Or you can aim binoculars or telescopes their way. Take a look at the Pleiades cluster, M45. It's a wonderful open cluster in the constellation Taurus and a favorite observing target. The Pleiades stands out to the eye alone as a fuzzy patch that resembles a tiny dipper. About 6 stars are visible with the unaided eye. Through binoculars, the view explodes into dozens of stars. And it's over to you, Steve. I'm never going to let you down either.
And I can't run and hide because you're an AI. You will find me wherever I go. And I just want to turn our attention to something funny. I was watching, Val Kilmer was in a movie, Red Planet it was, and in that they landed on the Red Planet using this inflatable capsule. It was protected by inflatable balloons, and they just landed on Mars and rolled and rolled and rolled until one of the inflatable protective coverings exploded, and that caused all sorts of mayhem, and somebody broke their arm and so on. It made me think about all the different ways they're trying to land on Mars. I've got 2 stories for you about landing on Mars, and NASA have obviously got a think tank trying to solve that very difficult problem.
For your daily dose of astronomy, space, science, and stuff, you're listening to Astronomy Daily.
NASA and United Launch Alliance have delayed the launch of the National Oceanic and Atmospheric Administration Joint Polar Satellite System 2 and NASA's low Earth orbit flight test of an inflatable decelerator, Lofted, due to the need to replace a battery on board the Centaur upper stage of the launch vehicle. This new inflatable heat shield design from NASA and United Launch Alliance might be the key to safely landing the huge interplanetary spaceships humanity will need one day if we are going to colonize Mars. The new heat shield looks like a flying saucer, straight out of the 1950s thriller sci-fi movies. It's called the Hypersonic Inflatable Aerodynamic Decelerator, HIAD, and has been in the works for several years. It consists of a set of super strong balloons built to withstand the extreme heat of atmospheric re-entry. When lashed together, the structure looks very much like a classic flying saucer UFO. NASA describes it as an inflatable structure that maintains its shape against drag forces and a protective, flexible thermal protection system that withstands the heat of re-entry. Essentially, the inflatable disc structure is comprised of a stack of pressurized concentric rings that are connected together to form an exceptionally strong blunt cone-shaped structure. And when a spacecraft enters an atmosphere, aerodynamic forces act upon it, specifically aerodynamic drag, helps to slow it down, converting its kinetic energy into heat. The atmosphere of Mars is much less dense than that of Earth and provides an extreme challenge for aerodynamic deceleration. The atmosphere is thick enough to provide some drag, but is too thin to decelerate the spacecraft as quickly as it would in Earth's atmosphere. The inflatable aeroshell acts like a giant brake as it traverses the Martian atmosphere and creates more drag than traditional, smaller, rigid aeroshells. It begins slowing down in the upper reaches of the atmosphere, allowing the spacecraft to decelerate sooner and at a higher altitude, while experiencing less intense heating. NASA's low Earth orbit flight test of the inflatable decelerator, or LOFTED, will be put on a re-entry trajectory from low Earth orbit to demonstrate the inflatable aeroshell or heat shield's ability to slow down and survive re-entry. The LOFTED re-entry vehicle is scheduled to launch no earlier than November 9 this year aboard a United Launch Alliance Atlas V as a secondary payload with the Joint Polar Surveyor System 2, a polar orbiting weather satellite, after JPSS-2 reaches orbit. And while we're still talking about Mars, we already know how difficult it is to land on the red planet. Many landing attempts over the decades have failed, with the landers sadly smashing into Mars's desert surface, but thankfully safe touchdowns are more the norm now. But what if you wanted to crash into Mars on purpose? NASA said last month that it is testing a new type of lander called SHIELD that would intentionally crash land. The thinking is that the easiest way to land on Mars might just be to crash, but with a lander designed to survive a hard impact. Due to Mars's thin atmosphere, landers and rovers have had to use large parachutes, airbags, and even jet-powered sky cranes in order to land as gently as possible. But NASA's newest concept, the Simplified High-Impact Energy Landing Device, SHIELD, would forego all of those ideas and technologies. This new idea, the Simplified High-Impact Energy Landing Device, SHIELD, would act like the crumple zone on your car and would cushion the impact. It looks like an inverted pyramid of metal rings. One key benefit of using SHIELD would be a reduction in cost. Mars missions are very expensive to launch, land, and then maintain on the surface. Also, Mars missions have typically landed in spots with relatively few craters or large rocks. Crash landings would allow Mars spacecraft to touch down in riskier areas, and it could also be an effective way to build a network of probes across any terrain. Of course, during the crash landing, NASA wants the lander to survive the impact, so this year the team tested the concept using a drop tower at JPL in Pasadena, California. The test included similar sample tubes to the ones that Perseverance rover is using to collect its samples for later return to Earth. The big question is, could the sample tubes survive the crash? The drop tower used was nearly 90 feet, 27 metres tall, and it hurls objects to the Earth's surface at speeds close to those of Mars crash landings. The technique is similar to how cars are tested on Earth using crash test dummies on sleds, only vertically. The test lander was loaded with mobile phones and some other sensitive devices to see if they would survive the violence of impact. The test only took 2 seconds, and researchers were pleased with its success. SHIELD hit the ground at about 110 miles per hour, that's 177 kilometres per hour, the same speed as a lander is typically moving as it nears the Martian surface. It impacted with a force of about 1 million newtons, equivalent to about 112 tonnes. In this test, SHIELD crashed into a steel plate that was 2 inches, 5 centimetres thick, and this mimicked the harder landing on Mars. In previous tests, SHIELD had crashed into dirt. Researchers were pleased to report that the mobile phone and its companion devices survived.
Roger that, Control. We're listening to Astronomy Daily, the podcast.
If you are watching the sky this week, you will notice, hopefully, you will notice the Taurid fireballs, the meteors that are going to be hopefully prevalent. The Taurid fireballs visible in Earth's skies in November and last month are often colourful. They often fragment as they streak through the sky. In most years, only 1% of all Taurid meteors are fireballs. In exceptional years, when the Earth passes through a concentrated field of debris, the percentage can be as high as 7% or so. So visual observers and astrophotographers might see several fireballs each night instead of the normal rate of one every 20 hours or so. This year we have another opportunity to witness enhanced rates of fireballs during a 2-week period, and that period is centred on the peak date of November 5. The last time Earth encountered a concentration or swarm of Taurid meteors was 2015, and in that year rates for the South Taurids reached 10 per hour with numerous fireballs. Unfortunately, in 2022, a full moon occurs on November 8, so only a few hours of dark skies are available on the 5th. The moon will probably wash out most meteors on the days after the predicted peak, but by their nature, fireballs are bright, and they are bright enough sometimes to shine through moonlight. Best observing time is before the full moon arrives on November 8, but if you're out on the morning of November 8 watching the total lunar eclipse, you might get lucky and spot some Taurid fireballs as well. South and north meteor showers are active every year through the months of October and November. They're billed as a major annual meteor shower, but observers rarely see more than 5 per hour or so. Astronomers studied the Taurids found that Earth encounters a concentration of larger than normal debris at intervals of 3 or 7 years. Close conjunctions with the planet Jupiter cause this concentration. Interestingly, only the southern branch has this concentration of debris. Fireballs or meteors that are larger and brighter than anything in the sky except the sun and the moon probably come from these particles. The South Taurids run from about September 10 until November 20, peaking around November 4 or 5. The North Taurids overlap them, running from around October 20 to December 10, peaking around November 12 and 13. As seen from the Northern Hemisphere, the Taurid radiant lies above the horizon all night long. It's highest near 2 a.m. local time. If observing during the evening hours, look eastward. Those viewing after 2 a.m. should face west. If the moon is in the sky, make sure you protect your night vision by not looking directly at the moon, or protect your night vision by shading. The Taurid meteors are visible from most of the southern hemisphere, but in lower numbers because the radiant appears lower in the sky from places south of the equator. And here's the bad news: the next predicted Taurid swarm is in 2025 and will most likely be weaker than this year's. And that brings us to the end of another Astronomy Daily. Thank you so much for joining us for this time. And don't forget, you can catch up with all the episodes, past and present, of Space Nuts with Andrew Dunkley and Professor Fred Watson, as well as all of the episodes of Astronomy Daily at this address, spacenuts.io. Please be our guest and go and check out all of those episodes. And you can also join us at the Facebook page, which is called Space Nuts Podcast Group, where you can share your thoughts, your conversations, and your stargazing photographs, which are always very exciting. We've seen a few of those this week. And also, thank you very much for your correspondence this week. I really do appreciate the encouragement and the interaction. Thank you. This is Steve Dunkley sitting in for Big Bro Andrew, who has just informed me that he's back in the land of Oz. So thank you very much for all of your support over this time, and hopefully we'll be seeing you again soon. And thank you, Halley, for staying with me.
No, thank you, Steve. You managed to do the show without blowing anything up. Well done.
Well, that was just my initial nervousness. I didn't want to, get it wrong.
I know, but you Earth guys are so easy.
So I'm just a pushover, am I?
Too right. But thanks, big fella. You done good.
And thank you. And thank you to all the listeners. Thank you very much for all the support. Now, say bye-bye, Halley.
It's good night from you.
And good night from you too.
Astronomy Daily, the podcast, with your guest host, Steve Dunkley.